Jai Hind students, welcome to my YouTube channel. Students, before we begin, I would like to share a thought. We cannot make our life worth living if we are not interested, or rather try to make it worth living for others. What I mean to say is that if I want to be happy, then I must try to make others happy. If we try to seek happiness at the expense of others, then students, believe me, we will be missing out on the golden aim of our life. That is, to be happy and to make every other person in this world happy as well. Right? So, with that students, let's begin this session. This will be a very interesting topic which we'll be dealing with this particular session, and the topic is cyclotron. It is a device, very useful device. Actually, it is a particle accelerator. It is a charged particle accelerator, and it is also known as magnetic resonance accelerator. Accelerator means it is a device or an arrangement which can make the charged particle to accelerate so as to gain in speed, so as to gain in energy. So when such highly energetic charged particle is made to hit a target, then it will be able to carry out nuclear reactions. It will be able to carry out nuclear disintegration process. So basically, cyclotron is a particle accelerator. Students, cyclotron can be used to accelerate proton, deuteron, or even alpha particle. I mean positively charged particles, right? And it was first designed by Lawrence and Livingstone in the year 1931, and it is also known as magnetic resonance accelerator, right? Now, regarding its principle, for that you need to understand 2-3 basic points which you should be aware of. Then only you will be able to understand the principle and the working. First point, students, we are already aware the electric field inside a conductor is always zero. Second, very important point, students, whenever a charged particle is in motion and if its direction of motion is perpendicular to the magnetic field, then it will experience a magnetic force, which is magnetic Lorentz force, which will make the charged particle to follow a circular path. So, the magnetic force acting on the charged particle under the influence of perpendicular magnetic field will make the charged particle to change its direction continuously without there being any change in the speed, right? So, it will tend to follow a circular path, right? And these are the two very important points so as to make ourselves convinced regarding the working and the principle of cyclotron. So students, the working of cyclotron is based on the principle that when a charged particle, positively charged particle, either proton, deuteron or alpha particle, is made to cross again and again the same alternating electric field, then it will get sufficiently energized. Now, when the charged particle is under the influence of electric field, what happens? It will experience electric force, and that electric force will make the charged particle to accelerate, in the sense that it will make the charged particle to increase its speed, right? And this is done by making the charged particle to follow a spiral path under the influence of strong perpendicular magnetic field. So here we will see how the charged particle will be made to follow a spiral path, and during each step its speed will increase after following a semicircular path. So as a result, it will tend to follow a spiral path under the influence of strong perpendicular magnetic field and as well as alternating electric field. So I repeat, students, the working of cyclotron is based on the principle that when a charged particle is made to cross again and again the same alternating electric field, when the charged particle is made to cross again and again the same alternating electric field, then it will get sufficiently energized. And this is done by making the charged particle to follow a spiral path under the influence of strong perpendicular magnetic field. Right? So here we will make use of a source of alternating electric field which is known as high frequency oscillator or high tension oscillator. So suppose this is the source, high frequency oscillator or high tension oscillator, right? So what happens is, if initially suppose this is at higher potential and this is at lower potential, then alternating electric field means it will change its polarity after definite interval of time. So after definite interval time, its polarity will get reversed and then again it will change. So during the time one cycle is completed, that is known as the time period. Capital T will consider it to be the time period. Capital T will be considered to be the time period of the oscillating electric field. So students, this is the alternating electric field. The direction of the electric field at this instant would be from positive to negative. After some regular interval of time, that is capital T by 2, half time period, the direction of the electric field would be like this. Then again it will get changed. So this is the direction of the electric field. So that's why it's alternating electric field, changing its direction periodically, right? So when the charged particle is made to cross time and again across the same alternating electric field, then at every step, whenever it is under the influence of this electric field, its speed increases because of the accelerating electric force, right? So as a result, it gets sufficiently energized, and the magnetic field which will apply perpendicular to the direction of motion of the charged particle, it will make the charged particle to follow circular path. So overall effect of this electric field and the magnetic field would be that the charged particle can be made to follow a spiral path, and in the process it will keep on gaining more and more energy due to the increase in its speed, right? And with such enormous energy, when it is made to strike the target, it is able to carry out the nuclear disintegration process. So that's the purpose of a cyclotron, right? So before we start discussing about the construction, then its working, the mathematical expression, students, I would like you to watch a short clipping based on the construction and the working of cyclotron. I'm sure you will love to enjoy it and you will understand the minute details of the construction and the working of cyclotron. Then I'll try to recap the entire thing.
A cyclotron consists of two flat semicircular metal boxes called Ds and are arranged with a small gap between them. A source of ions is located near the midpoint of the gap between the two Ds. The Ds are connected to the terminals of a radio frequency oscillator or a high tension oscillator so that a high frequency alternating potential of several million cycles per second exists between the Ds. The Ds are enclosed in an insulated metal box containing gas at low pressure. The whole apparatus is placed between the poles of a strong electromagnet which provides a magnetic field perpendicular to the plane of the Ds. The positive ions produced from a source at the center are accelerated by a D which is at the negative potential at that moment. So the positive charged particle will experience an electric force due to the positive and the negative polarity of the two Ds. So as a result, it will get accelerated towards the negative D. Now, the electric field inside a conductor is always zero. Thus, the positive charged particle on entering a D will be only under the influence of magnetic field. The direction of motion of the charged particle being perpendicular to the magnetic field, the charged particle experiences a magnetic force which will make the particle to follow a circular path inside the D. This is due to the magnetic Lorentz force. The condition of working of cyclotron is that the frequency of radio frequency alternating potential must be equal to the frequency of revolution of the charged particle within the Ds. This is called resonance condition. Now, as the charged particle comes in the gap between the two Ds, the polarity of the Ds get reversed. Now again, in the gap between the two Ds, the charged particle under the influence of electric field will get accelerated and it will enter the other D with higher velocity. And again, inside the D, it will be only under the influence of magnetic field and its direction of motion being perpendicular to the magnetic field. Now it will follow a semicircular path of larger radius. The radius of the semicircular path followed by the charged particle is given by R is equal to mv divided by qb. So as the speed of the charged particle increases, it tends to follow the semicircular path of greater radius. Therefore, due to the presence of perpendicular magnetic field, the ion will move in a circular path inside the D, and the magnetic field and the frequency of the applied voltages are so chosen that as the ion comes out of a D, the Ds change their polarity, that is, positive becoming negative and vice versa. And hence, the ion is further accelerated and moves with higher velocity along a circular path of greater radius. So this process continues, and as a result, the charged particle keeps on gaining energy. The time period of the oscillating electric field is given by T is equal to 2 pi m divided by qb. A question may arise that the time period taken by the charged particle will keep on increasing with the increase in the radius of the semicircular path. But it is not so, as the decrease in the time spent by the charged particle inside a D due to the increase in its velocity is exactly compensated by the increase in the length of the semicircular path. The phenomena is continued till the ion reaches at the periphery of the Ds, where an auxiliary negative electrode deflecting plate deflects the accelerated ion on the target to be bombarded.
After watching this short clipping, I hope most of the things regarding the construction and the working of cyclotron must be clear. Anyways, I will recap the entire thing, right? Let's start with the construction. Now, as we are aware, students, a cyclotron consists of two large semicircular hollow chambers which are known as Ds, right? So, concentrate on the diagram. So, in order to make the Ds, draw an ellipse like this, just to give it a 3D shape. Okay. These are the two Ds I am trying to draw. These are the two Ds. This is one of the D, right? And this is the second D. These are, as I told you, large, hollow, semicircular chambers. So these are the two Ds under consideration. These are the two Ds. So they are in the horizontal plane, and these two Ds are placed with a small gap between them. This is a small gap between them. This is a small gap between them. So they are known as Ds, which is D1 and D2. These are the two Ds. It can be considered to be D1 and it can be considered to be D2. Right? These are the Ds. And these two Ds, students, they are connected to a source of high tension oscillator or high frequency oscillator. So, these are the two Ds connected to HPO or HFO. This is a source. This is a source. It will provide an alternating electric field, a strong alternating electric field, and the time period of the oscillating electric field will be considered to be capital T. Right? This is the time period. This is the time period of the oscillating electric field. Now, this is the center, suppose, where the charged particle, that is the proton, neutron or alpha particle, will be assumed to be placed initially. Now students, here I would like to mention that these two Ds are enclosed in a metallic chamber which is maintained at a very low pressure. Now in order to produce a proton, that metallic chamber is filled with hydrogen gas, and in order to produce alpha particle, the metallic chamber which is maintained at low pressure is filled with helium gas, right? So this is the chamber in which this entire arrangement is enclosed, and as I have stated, it's in the horizontal plane. So students, I repeat, a cyclotron consists of two large hollow semicircular chambers D1 and D2 known as Ds. They are placed on a horizontal plane with a small gap between them, and these two Ds are connected to a source of high tension oscillator or high frequency oscillator, which acts as a source of strong alternating electric field, right? And the entire arrangement is enclosed in a chamber which is filled with some gas at extremely low pressure, right? And it is placed between the two poles of a strong electromagnet, right? Suppose it's like this. Let us consider this to be south pole and this to be north pole. So the magnetic field would be like this. This is the direction of the magnetic field. It will be obviously perpendicular to the plane of the Ds. So students, the direction of the magnetic field is perpendicular to the plane of the Ds, right? So this is regarding the construction. So we are over with the intro, the principle as well as the construction. Now let's concentrate on its working, which is very important. Suppose initially the charged particle is at point O. Now at that instant, suppose it is at higher potential and it is at lower potential. So obviously electric field will be set up along this direction from positive to negative. So this being positively charged particle, it will get attracted towards D2, towards the negative D, isn't it? It will experience an electric force, right, along the direction of the electric field, and it will enter D2 like this. It will enter D2. Now as the charged particle enters the chamber D2, then inside the chamber the electric field will become zero. It will cease to exist. So inside chamber D2, the charged particle will be only under the influence of perpendicular magnetic field. And students, its direction of motion being perpendicular to the magnetic field, it will experience a magnetic Lorentz force which will make it to follow a curved path, right? It will make it follow a circular path like this. Now students, as the charged particles comes in the gap between the two Ds, the polarity of the Ds get reversed. So now this will be at lower potential and this will be at higher potential. So at this juncture, this charged particle will get attracted towards D1. So again it comes under the influence of electric force. So as a result it gets accelerated. So the electric force acting on the charged particle in the gap between the two Ds will make the charged particle to increase its speed, right? So as a result, now its speed will get increased, and with that increased speed it will enter metallic chamber D1, where again inside the metallic chamber the electric field will be zero. So the charged particle, once it enters D1, it will be only under the influence of magnetic field, and that too perpendicular magnetic field. So again magnetic Lorentz force which will be acting on the charged particle will make the charged particle to follow a semicircular path of greater radius. So like this. Again, as the charged particle comes in the gap between the two Ds, again the polarity of the D's get reversed. So now it will be positive, it will be negative. Again the same process continues. That is, this charged particle in the gap between the two Ds will again come under the influence of electric field. Hence it will experience electric force, due to which it will get accelerated. As a result, its speed will increase, and with that increasing speed it will enter chamber D2, where it will be again only and only under the influence of magnetic field, which will make the charged particle to experience a magnetic Lorentz force, which will enable it to follow another semicircular path of larger radius. And this semicircular path will be followed by the charged particle with greater speed, right? So this continues, and as a result, the charged particle tends to follow a spiral path. It tends to follow a spiral path. And eventually and ultimately, when it reaches the periphery, that is, when the charged particle follows a semicircular path of maximum radius, then it will possess maximum kinetic energy. That will derive an expression for that. And then with the help of negative electrode, the path of the charged particle is altered, right? So as to enable it to make an exit from this window. And then it is made to hit the target. So this is suppose the target. So now concentrate on the principle, what I have stated. Again, I will repeat that. Students, the working of cyclotron is based on the fact that when a positive charged particle, it may be proton, neutron or an alpha particle, when this positive charged particle is made to cross again and again the same alternating electric field, it is crossing this alternating electric field again and again, isn't it? Then it will get sufficiently energized, because at each step when it comes in the gap between the two Ds, it will get accelerated, its speed increases. So when the charged particle is made to cross again and again the same alternating electric field, then it gets sufficiently energized. And students, this is done by making the charged particle to follow a spiral path under the influence of strong perpendicular magnetic field. Clear, students? So this is how the charged particle is able to get sufficiently energized, and then it is able to hit the target with tremendous energy and is capable of carrying out nuclear reactions, right? So this is the scheme of thing on which the cyclotron works. Now let's find its mathematical expression. One thing should be noted, students. Whenever the charged particle comes in the gap between the two Ds, then only the polarity of the Ds get reversed. For that to happen, students, the time spent by the charged particle inside a D must be constant. It is only then the synchronization can be maintained, or else the charged particle will start lagging behind the oscillating electric field and it would eventually be lost by colliding against the wall of the Ds. So it won't get accelerated, or it won't get accelerated through the particle accelerator, right? It won't do its purpose. So basically, the most important point to be remembered, students, there should be a synchronization. What I mean to say is that the time spent by a charged particle inside a D must be constant. It shouldn't be dependent upon the speed or the radius of the semicircular path which it follows. It simply means that a charged particle will spend same time inside a D, whether it is following a semicircular path of smaller radius or it is following a semicircular path of larger radius. Students, you might say, how is it possible? Now look, there is a simple theoretical justification. The decrease in the time spent by the charged particle inside a D on account of increase in its speed is exactly compensated by the increase in the length of the semicircular path. So that is how the time spent by the charged particle inside a D can remain constant. It is independent of the radius of the circular path, nor it depends upon the speed of the charged particle. We'll prove it mathematically as well, right? So let's now deal with the mathematical expressions. So what to do is, let's consider any arbitrary semicircular path, say of radius r, and suppose it is following this path with speed v, right? So we are aware when the charged particle is inside inside the chamber, it will be only and only under the influence of magnetic force, and magnetic force experienced by the charged particle is given by q v vector cross b vector. Here students, velocity vector is perpendicular to the magnetic field. Direction of motion of the charged particle is in the horizontal plane, while magnetic field is perpendicular. So v vector is perpendicular to b vector. So the magnitude of the magnetic force is given by q vb sine 90. Sine 90 is 1, so we'll get q vb. Now as we are aware, the work done by the magnetic force is always 0. So this force acting on the charged particle will make the charged particle to change its direction continuously without resulting into any change in its speed. So when the direction of motion of the charged particle changes continuously, it means that it will follow a semicircular path inside the D, which means that the nature of the magnetic force must be centripetal, right? So therefore, Fm is equal to Fc. That is, the magnetic force acting on the charged particle inside the chamber will provide the particle the necessary centripetal force so as to enable it to follow a semicircular path inside the D. So therefore what you get is QVB is equal to centripetal force, we are aware it's mv square by r. So VV get cancelled. So R is equal to mv divided by QV. Students, this is the expression for the radius of the semicircular path which the charged particle will follow. Right? Now let's find out the time which a charged particle spends inside a D. So time spent by the charged particle. Suppose it is given by t. So it will be distance over speed obviously. So semicircular path, total distance will be pi r divided by with what speed it covers. We have considered this arbitrary semicircular path to be covered by the charged particle with speed v. Right? So let's substitute the value of r over here. So what do you get? T is equal to pi. R is mv by qv. Vv get cancelled. So pi m divided by qv. Now look students. Magnetic field is uniform, that is constant. Charge, it is constant, it won't change. Mass, it won't change. In mechanics, mass of a body is always constant. Pi is constant, so this is constant. So we have proved that the time spent by a charged particle inside a D, whether it is following a semicircular path of smaller radius or it is following a semicircular path of larger radius, the time spent by the charged particle is constant. So that is how the synchronization is maintained. That is, whenever the charged particle comes in the gap between the two Ds, then only the polarity of these two Ds get reversed. So there is perfect synchronization between the oscillating electric field and this time t. There is a perfect relationship between them, right? So let's try to understand that relation. Suppose students, t is the time period of the oscillating electric field. Now look, when it is of higher potential, it is at lower potential, then during this half time period, it will cover one semicircular path. Then again, the polarity will get reversed during other half time period. So during that, it will cover another semicircular path in the other chamber, isn't it? So what is the relationship between capital T and small t? Obviously, it must be capital T is equal to twice into small t. During the time period of the oscillating electric field, the charged particle will follow a semicircular path twice of unequal radius obviously in both the chambers, in each of these two chambers. Clear, students? Look, again, I'll try to justify this. This is the high tension oscillator, right? Suppose it is at positive potential, it is at negative potential. Again, after T by 2, after half time period of the oscillating electric field, its polarity will get changed, and then again after half time period of the oscillating electric field, again the polarity will get reversed, isn't it? So T by 2, T by 2. So during one complete period, capital T, the charged particle will follow a semicircular path inside D1, and then it will follow another semicircular path of greater radius inside D2, consuming same time inside each of the two T's. Therefore, the relationship between capital T and small t must be capital T is equal to twice small t. Clear, students? During this half, it will cover a semicircular path in one of the chamber, and during the second half period of the oscillating electric field, it will cover another semicircular path of larger radius with greater speed in the other chamber. So, but obvious that capital T and small t are related by this relationship, capital T equals to twice small t. So, what about the time period of the oscillating electric field then? It will be given by twice, substitute the value small t, it is pi m divided by qb. So, this is the time period of the oscillating electric field, right? What about the frequency of the oscillating electric field? So, that will be reciprocal of this. So, it will be given by qb divided by 2 pi m. So, students, this is the expression for the frequency of the oscillating electric field. Now, we can also find out the expression for the angular frequency, right? So, what about angular frequency? Angular frequency would be given by, over here, let's write over here. It is 2 pi nu. So, substitute this value nu over here, what do we get? qb divided by m. So, this is the expression for the angular frequency of the oscillating electric field. So, students, these are some very, very important expressions. Again, I repeat, this is the expression for the time spent by a charged particle inside a D, and it is constant. This is the time period of the oscillating electric field, right? It is equal to twice of small t. Reciprocal of time period, that will give us linear frequency, and angular frequency is 2 pi by capital T or 2 pi nu. This is the expression for the angular frequency of the oscillating electric field, or it is known as the angular frequency of the cyclotron, right? Now let's find out the expression for the maximum kinetic energy possessed by the charged particle, right? So for that, we need to find out the maximum velocity. Okay, let's find out. Expression for maximum kinetic energy. Now look, students, kinetic energy is half mv square. So when velocity is maximum, then obviously kinetic energy would be also maximum, isn't it? And from here we can substitute the value of v. V can be written as qb divided by m into r. Now look, this is a constant term, charge, magnetic field m, they are constant. If r is maximum, then v would be also maximum. It's pretty clear. So students, when the charged particle follows the semicircular path of maximum radius, then it possesses maximum speed. So it is this stage when it is said to be most energetic. And with such high energy, when it is made to strike the target, then it is capable of carrying out nuclear reactions, right? Anyways, let's find out the expression for the kinetic energy then. So maximum kinetic energy would be equal to half m. Let's substitute the value of V max. It would be QB R max divided by m and whole square, right? So what we get is maximum kinetic energy which the charged particle, positively charged particle will possess is Q square B square R max square divided by twice into m. So this is the expression for the maximum kinetic energy which the charged particle will possess. And this is huge. With this huge kinetic energy, when it strikes the target, it is able to do its work of nuclear disintegration. Right? So now students, we have done its working as well as we have derived all the mathematical expressions which are relevant to this particular topic. Right? Now let's discuss some limitations. Right? This is again a very, very important thing which we need to discuss. There are some drawbacks of cyclotron, and there are various methods also to overcome those drawbacks. So let's discuss some limitations of a cyclotron. Okay. Limitations or drawbacks. Most importantly, students, when we are talking about that the speed of the charged particle increases stepwise, right? We are talking about very, very high speed. When the speed of the charged particle becomes comparable to the speed of the light, then due to the relativistic variation in mass, the mass of the charged particle also tends to vary as per this relation. So due to relativistic variation in the mass of the charged particle is given by m0 divided by square root of 1 minus v square by c square. Now this is the expression for the relativistic mass. You must remember it's given by Einstein, isn't it? Anyway, m0 is the rest mass of the charged particle. M is the mass of the charged particle when it is moving with speed v. C is the speed of light, which is 3 into 10 to the power 8 meter per second. Clear, students? So mass of the charged particle will also vary with its speed when the speed of the charged particle is comparable to the speed of the light. And this variation in mass, students, is known as the relativistic variation in mass. Right? Now, the time spent by the charged particle is given by this formula. Now, if the mass of the charged particle starts varying, then the time spent by the charged particle is given by time spent by the charged particle inside a d is given by, just substitute the value of small m over here, pi by qb, this is pi, and substitute the value of m over here. It is m0 divided by square root of 1 minus v square by c square. Now look, students, for perfect synchronization small t should be constant, but now what happens is with the change in the speed of the charged particle, at each and every step, whenever the charged particle comes in the gap between the two Ds, its speed increases, isn't it? So with the increase in the speed, time t will also vary. So the synchronization won't be there in this case. Now t won't be constant, isn't it? Again, let me convince you. Now with the increase in the speed of the charged particle, what happens is this term, square root of 1 minus v square by c square, will be decreasing. So when the denominator decreases, the numerator or the fraction also increases. So what I mean to say is that as v increases, t also increases. That is, with the increase in the speed of the charged particle, the charged particle starts spending more and more time inside the d. That is, small t also increases. Now as small t is now not constant, it is increasing. Therefore what happens is the charged particle starts lagging behind the oscillating electric field. In such a scenario, what might happen is the polarity of the D's might get changed and the charged particle might be inside a chamber instead of in the gap between the two Ds. Clear? So in such a case, what happens is the charged particle starts lagging behind the oscillating electric field. And eventually what will happen is, after it starts lagging behind the oscillating electric field, it will simply be lost by colliding against the wall of the Ds. Clear? So this is one of the main drawback. So again I repeat this important limitation. With the increase in the speed of the charged particle, when the charged particle acquires tremendous speed which is comparable to the speed of light, then the mass of the charged particle won't remain constant. It will also vary according to the relativistic variation in its mass. In such a scenario, the charged particle will start spending more and more time inside the D, and as a result it will start lagging behind the oscillating electric field, and eventually it will be lost by colliding against the wall of the Ds. Now students, let us go in detail. This limitations, it can be overcome by two ways. This limitation can be overcome by two ways. First is the strength of the magnetic field. Remember, these are the poles of an electromagnet. Its strength can be increased or decreased by increasing or decreasing the current, isn't it? So these are the poles of a strong electromagnet. So the magnetic field can be varied. So by varying the magnetic field, T can be made constant. In spite of the fact that V increases, so the mass of the charged particle also increases. Therefore, the strength of the magnetic field may be also increased proportionately, so that the value of small t can remain constant. So by changing, or rather by increasing the strength of the magnetic field, the time t can be kept constant. And such a cyclotron which employs this method, that is, the strength of the magnetic field is varied so as to keep small t constant, is known as synchrotron. Such a cyclotron is known as a synchrotron. Students, the second way of overcoming the limitation of cyclotron is by making the change in the frequency or the time period of the oscillating electric field. What I'm going to say is that, students, as we are aware, the time spent by a charged particle inside a D is given by this, isn't it? Now, as with the passage of time, as the speed of the charged particle increases, the charged particle starts spending more and more time inside a D, and as a result, T is not constant, isn't it? So therefore, capital T is equal to twice small t. This relationship will not hold valid, isn't it? So that this relationship always holds valid. As T varies, the capital T can also be varied, so that the relationship capital T is equal to twice into small t always remains same. So that is possible only by changing or by varying the time period of the high tension oscillator, or by changing the frequency or the time period of high frequency oscillator. So students, a cyclotron which makes or which employs this method so as to overcome the above drawback is known as Synchro Cyclotron. So students, Synchro Cyclotron. So this is a cyclotron in which the time period or the frequency of this high frequency oscillator is varied so as to keep this relationship valid, so as to keep the synchronization intact. That is, the polarity of the D's get changed only when the charged particle comes in the gap between the two D's. Clear, students? So these are the two modes, or these are the two ways in which the limitations can be overcome. First, by varying the strength of the magnetic field, that is known as synchrotron, and second, by varying the frequency of the time period of the high frequency oscillator, right? That is known as synchro cyclotron. There is, students, one more drawback of a cyclotron. A cyclotron cannot be used to accelerate electrons. It is a negatively charged particle. So let's discuss this. This is a very, very important a cyclotron cannot be used to accelerate electrons. Why? Let me justify it. Now students, you are aware the mass of an electron is negligible. It is about 9.1 into 10 raised to the power minus 31 kg. It's too small. Now, when it is under the influence of accelerating force, electric force, then what happens is the acceleration experienced by the electron would be F by m as per Newton's second law, isn't it? Mass is too small, therefore acceleration would be too large. So, acceleration would be too large. So, what I mean to say is that owing to extremely small mass of an electron, it will get accelerated to a huge value. It will get accelerated to a huge value. It means that an electron tends to acquire tremendous velocity in very, very small time. So as a result, an electron immediately goes out of step with the oscillating electric field and starts lagging behind, and as a result, it is lost by colliding against the wall of the D's. So students, this is the reason why a cyclotron cannot be used to accelerate negatively charged particles like an electron, because it acquires very high speed in very small time. So it immediately goes out of step with the oscillating electric field. Right students? So it is impossible to maintain the synchronization in case of an electron. So that's the reason. So I hope students you have understood this topic of cyclotron completely, right? We have discussed each and every part of this topic in detail. So please go through this topic again and again, watch the video and do practice. Do practice drawing the diagram of this cyclotron, as it's a very, very important question. It can come in the long answer question type category, in the 5 marks category, right? So that's it for this particular session. Do join me in my next lecture. Till then, do take very good care of yourself and stay blessed. Thank you.